design the different types of digital filters, transforms that, and other type of algorithms that, because nowadays if we talk about that, as I remember that, I think in 1 year back I delivered same Atal FTP lecture that, and that time I enlighten roughly around 34 areas that where VLSI contributed in background that. So VLSI has very big aura that it did not get possible to enlighten each and everything within 1.5 hour that. But if we talk about that, uh, signal processing, especially in terms of algorithm, then first one is digital filter. In that digital filter, there is a most popular is FIR, IIR, and adaptive filters. That basically these filters get used like audio processing, communication, and image processing. That if we talk about that, another type of algorithm, it's called Fourier transform. That if we talk about that Fourier transform, uh, then there is a several type of Fourier transform. Out of them, one is fast Fourier transform. It is basically used for spectral analysis, modulation, demodulation, data compression, and basically by using the VLSI architecture, we can implement the FFT algorithm efficiently for real-time processing. Then another type of transform, here I try to give idea about what are the various popular algorithms in signal processing. If we talk about that, another type of popular transform is Babler transform. You can understand that Babler transform had how much contributions that across world roughly till now more than 500 PhD thesis already completed on only Babler transform area that. So you can understand that how this big area that and what are the broaden scope that basically Babel transform will used in a signal compressions, noise reductions, feature extractions, and many other small domains also. That. If we talk about that, modulation and demodulations, that modulation, demodulations, or QAM, PSK, and OFDM, these are frequently used in communication systems. That and there is a possibility to design the architecture via VLSI. That if we talk about that compression algorithms, that uh, are like many signal compressions are like a JPG, MP3, and H264.
Sir, I think the PPT is not moving. Means the
No, no,
slide is it pushed?
I am in just first PPT only signal
Oh,
processing algorithm.
okay, okay. Okay, sir.
So
Okay.
if we talk
Sir, can
about
you
that,
make it a full screen?
yeah, already make full screen. Is it not full screen?
No, sir, not. It is in display. Sir, I think we should do one thing.
Yeah.
After stopping the sharing, after making that PPT in slide mode, we need to share it as a full screen window as a full screen. Thereafter, it will be shared as complete.
Okay. Now it's in full screen mode. Okay.
Yes.
Okay. Hmm. Okay. Hmm. Okay. Sorry for technical glitch. I will share again that PPT. Hopefully now it get available in a full screen. Kindly confirm
Yes, sir.
once.
Yes, sir. It is available now, sir.
Okay, okay. So another type of popular algorithm is compression algorithms that compression algorithms like JPG. JPG is one of the image compression that, and then audio MP3 and then video MP4 that. So wait a minute. Okay. Now we talk that another terminology is that what are the VLSI design for signal processing? It's a little bit same like the other approaches that at first we design the algorithm specifications, then we do the high level synthesis. High level synthesis is basically programming based on BHDL Verilog system Verilog that, and then after we do the architecture design, then we do the RTL design stack, then physical design, then verifications, and at last fabrication we perform that. Okay. Now if we talk about that, what are the key component architectural components for designing any VLSI architecture for any signal processing. Then first one is that uh, hardware computing or computing hardware. Basically inside that there is a major components in multiplier and adders. And then another key components are register and memory. And then there is a popular optimizations techniques. Basically it get used every year for optimize the area power delay. It's a par, par, pipelining and parallelism stack. And then another one is that floating point and fixed point arithmetic stack. And at last one is that interconnect network stack. Now, if we go in computing, then there is a if you see that there is a two type of computing. One is exact computing and another one is approximate computing. Basically, nowadays both of approach are very popular approach for computational problems. That maybe if you are not working in that field, then when you listen my opinion, maybe you are start thinking that how are told that approximate computing is also nowadays using for computational problems. I give you a real time example that normally till now we know that 2 multiplied by 2 is equal to 4. But if we talk about that in VLSI, and if 2 multiplied by 2 equal to come 3.8, then it's also considered from several places. Now we see that what places it get considers that and why it is also important that we did not much focus on exact computing that, but talk is majorly focused on approximate computing. Now, big questions floating in your mind that how approximate computing is also useful. Many places that where 100% accuracies are not required. That if we see that exact computing, then there's a many areas that where accuracy or precision is the main important thing, like a financial calculation, cryptography, and many places that in that places exact computing is okay. But suppose that we have 5 or 20 terabyte data, and if we want to send that data then sending via internet is still 20 terabytes or 200 terabytes data is a very critical task. In that place, there is a role of compression that, and we know that compression means that quality get degraded. Quality degradation means what? Means that it did not 100% exact like that. Pixel valuations get degraded that. So, in such type of things in background, approximate computing is only used. Okay. What are the benefit of approximate computing is that I, from example, I clearly told that where efficiency or accuracy is the not topmost priority that, and priority is speed, priority is the performance, all those things. Approximate computing is the acceptable stat. There is a many places that it get used for what purpose? Faster execution, and another most important thing is that it reduces the resource usage. That, as I told that, where perfect solution is not necessary or trade-off between accuracy and resources, constraint can be made that approximate computing is the perfect computing. If we talk about that approximate computing, that there is a several approach of approximate computing that like a probabilistic algorithm, stochastic computing, and methods that are exploit redundancy to tolerate errors. These are the few types or subtypes of approximate computing that. If we talk about that, what are the broadened area of applications that, then basically image and signal processing is the bigger area where approximate computing get worked at. Machine learning is the another area that, and where there is a scope of optimizations that, or it is in that such places that definitely approximate computing is the most preferable or choiceable option in comparison of exact computing that, because it provides the better results in form of trade-off. Trade-off means that cost, area minimization, power minimization, and all those. I give you one real-time example that we can see that actually it did not exact example of approximate or exact computing that, but you can understand that. There is a mobile manufactured by Apple company and mobile manufactured by some Redmi or local company. That here brand name is not important that, but from brand name you can visualize the exact performance that due to I told the name that. Okay, so if you see these two companies that almost work quality is near to same that, but there is a cost by Apple mobiles cost is 5 to 6 times more for user prospect that. So mostly majorly people prefer to local brands or a small brands that. Why they prefer to a small brands that? Because they are also giving nearby the performance that. And here you can understand that the role of approximate computing. Approximate computing is giving the result nearby to exact computing that, but it has very low cost in the terms of area, low cost in the terms of power, low cost in the terms of performance that. So due to that, in real world, many places that approximate computing is the most choiceable things in comparison of other options that. Okay, if we talk about that the common type of approximate computing, then first one is the probabilistic computing that. Probabilistic computing is basically it's based on probability theory to approximate solutions to computational problems that. In that, basically, Monte Carlo methods uh, is used. It used for random sampling to estimate numerical results, the probabilistic data structure, which provide approximate answers with high probability. Normally, basically in game theory or such type of things, that probabilistic computing get used, that simply, if you watching the cricket match, that then they give the win probability, that like a few times, win probability shows something different and result something comes something different, suppose in a cricket match, that eighth player get playing match, and in a one over you need to make the 24 or 26 runs, that then win probability is that which team is bowling, that its win probability is roughly 90%, that. But cricket is a game of something new, that, and there is a possibility people can make this run, that. So those probabilities showing to 10%, they finally win that. But according to probability, that thing. So basically, probabilistic computing help you to perform in a way that, so we found the result which is maximum chance to happen, that, and this one is the one of the common type of approximate computing, that. Another type of approximate computing is error tolerant computing. uh, if we talk about that error tolerant computing, that many applications like multimedia processing, machine learning, and many other places, that where 100% accuracy is not required, that are like the image processing. So such places, that error tolerant computing get used, that we use such type of hardwares, that which power requirement, area requirements are minimum, that, but same time it can provide the high performance. Another type of approximate computing is that these are the two major type of approximate computing. First one is probabilistic, and another one is error tolerant computing. Now, if we talk about that approximate arithmetic, as I told, that like a computing hardware is majorly multiplier and adder, that. So here also, that if we talk about that approximate arithmetic, then majorly, if we talk about that approximate computing hardware, then there is a major two components, it multiplier and adder. And if we talk about that approximate arithmetic, then there is a first one is that fixed point arithmetic, and another one is that floating point arithmetic. So basically, we what techniques, if we talk about that approximate arithmetic, then basically we use the floating point approximation stat and fixed point arithmetic with reduced precision stat. Now, if we talk about that, what are the technique get used in approximate arithmetic, then there is one approach is selective precisions. In that, basically adjust the precision of computation dynamically based on requirement of applications. In that, many times happen that there is one application who has capability to give the result with 80% efficiency or give the result with 100% efficiency. In that, it changed the hardware requirements, that, and definitely it get used to minimize the power consumptions, as well as you can understand that it's from RAM requirements, that are if we run for fast, if we want to run fastly to process anything, that our RAM requirement get increased, that, and if we no require a fast process, then RAM requirement or RAM utilization will decrease that. Selective precision is same like that. In that we develop such type of application. So according to requirement of applications, it perform the computations. That. Now there is another term says that what are the approximate algorithms that. Now basically in that we discuss about that few selected approximate algorithms for multipliers and few selective algorithms for adder circuits. That. Before that, we do the general discussions in approximate algorithms that then there is a one popular algorithm, approximate algorithm is quantization stat. Basically, it reducing the precision of data or parameters in computational tasks that by quantizing data or parameter to a smaller set of discrete values. It's reduce the computational complexity and it's make the faster education with acceptable level of accuracy degradation. Another one is fuzzy computing. Fuzzy computing is also come under that probabilistic computing only. That basically fuzzy computing deal with uncertainty and impressions in data and computations that it allow for approximate reasoning and decision making based on fuzzy logic principle. Now we come on that approximate hardware computing stat. If we see that approximate hardware computing stat, then there is a majorly two components. One is approximate multipliers and another one is approximate adder stat. One by one, we discuss about that what is approximate multipliers, what are the popular approaches for implementing approximate multipliers. Then we discuss about that what is approximate adders and what are the popular approaches to implementing approximate adders. From name, it's very clear that it's a approach of multiplication which did not provide the exact result that it provides the approximate result that if we talk about that then there is a few popular techniques like approximate Booth encoding, logarithmic number system, low power carry sub adders. These are the few techniques which is used to perform approximate multipliers. That often it gets used in a neural network to reduce the hardware requirements and power consumptions of network while still maintaining acceptable level of accuracy. Now one by one I try to explain the various types of approximate multipliers. That if we talk about that then first, which one is the most popular is it's a Booth multiplier. That and as you are aware that Booth multipliers get implemented by a different approach like radix 4, radix 8, radix 16 stack. So there's a one popular approach is approximate radix 4 Booth multiplier. Basically in that what we do that it's in that basically we reduce the number of partial product generated during the multiplication by using Booth encoding. That it also use approximate or adder to reduce the accuracy of final result. If we see that step by step that then at first we group the multiplier bits into pairs, then encode each pair using Booth radix 4 rules. Then after we generate the partial product based on encoding, and then at last add the partial product, give the final result that with possible approximations. That another approach is that approximate Wallace tree multiplier. That it's a another type of approximate multiplier. That in that basically we perform the approximation in Wallace tree multiplier. In that basically we use the approximate adder and reduce the number of partial product, and we achieve the significant power saving in a approximate Wallace tree multiplier. There is another type of multiplier. It's a truncated multiplier. That truncated multiplier. Dr. Mohanty has done a lot of work on radix 4 booth multiplier or truncated multiplier. That he has very nice 4 or 5 article on IEEE transactions. That if you want, you can refer that. Truncation is very simple thing. Is that truncation means that those are unnecessary part that you can cut down that part several times, like when we do calculations. That suppose if we want to represent one number 29 via hardware, that then for 29 represented we needed a 5-bit multiplier. But suppose if we want to represent that 29.000087, that here if we exactly we try to do that things, in that condition we needed 16-bit multiplier or something. That means what happened, that 5-bit and 16-bit, that roughly 8 times or more than that your area, power and all those things get increased. And result is if we cut down the after decimal parts, that so result did not get affected even a 0.1% like that. So truncations or truncated multiplier work on that concept. That those are unnecessary part to cut down that parts. So result is not much affected, but we save lot of hardware resources. If we talk about the truncated multipliers, then there is a 3 type of truncated multiplier. One is post truncated multiplier, and another one is pre-truncated multiplier. That pre-truncated multiplier, that like if we want to multiply 19.002 and 20.002, then we cut down in initially only the after decimal parts, that and we multiply 20 multiply by 19, that. So this one is the called pre-truncations, because truncation we perform in initial case. That another one is that post-truncations. That post-truncation means that when output come, that then we discard the decimal parts. That and there is a one is between truncations, that during process of according to requirement we can do that. So these are the 3 sub approaches of truncation multipliers. That and it's much effective things. That out of another one is that approximate pipeline multipliers. That in that basically we use the pipeline architectures with a series of approximate adders to reduce the accuracy of the final result. Via that what happened, that accuracy is slightly affected, that but definitely our area requirements are decreases, that our power consumptions get reduced. That so this one is also another effective approach. That several times when we perform the pipelining, then we perform the approximate pipelining also, that so that way it get helpful. Another one is that approximate logarithmic multiplier. That basically approach behind that, actually I done my PhD in approximate logarithmic multiplier only. That so if you want I can give you whole day lecture on that, but we did not, time will permit regarding that. So here basically I give you a rough idea regarding logarithmic multiplier. Here, no need to mention the separately word of approximate because logarithmic multiplier perform in a approximation way only. That it did not provide the exact result. That it's a example of approximate multiplier. Basically, in that, if we want to multiply two numbers, that we did not directly multiply these two numbers. That basically, what we do that at first we take the numbers, convert the binary numbers of that, and take the log of that binary numbers that, and then after we add these two numbers log that and take the anti-log of that. So that way it's come to output which is approximate. That it did not exact that. Many cases it come exact, many cases it's come approximate that. If you want to understand the more about logarithmic multiplier, I have 2 or 3 nice work on that. You can refer that. It get published roughly in 2017 and 2018 that. And basically, via help of approximate logarithmic multiplier, we can develop the approximate adder also that. Now we come on that, several types of approximate adders that. It's a similar like that. Adders with some approximations that. So there is another type of approximate adder is ripple carry adder. Basically in that, till now, for adding, ripple carry adder is the best adder till now. That here in approximate version of the ripple carry adder can be created by reducing the number of logic gate or by introducing error tolerant components. If we talk about that, another type of popular adder is that carry skip adder. That it's another type of adder that, and we can develop the approximate version of carry skip order also that by sacrifice of precision by skipping carries in certain cases or by using the simplified carry prediction techniques. That another one is that carry select adder. If we want to develop the approximate version of carry select adder, it may optimize the selection logic to reduce area or power consumption at the expense of precision stack. Another one is carry look ahead adder. In carry look ahead adder, basically what we do that, we use the simplified or approximate logic to compute the carry signal, leading to faster but less precise results. Another one is approximate prefix adders. That prefix adder or also known as parallel prefix adder use a tree structure to compute sum and carries in parallel, which can improve performance compared to carry adders. That but in approximate version of prefix adder may use approximate carry computation technique or reduce precision arithmetic to speed up the addition process. That another one is approximate Wallace tree adder. That in approximate Wallace tree adder, what we do that we use the probabilistic technique to reduce the complexity or power consumption of the adders. Another one is that approximate carry sub adder. In that, in approximate version of carry sub adder, may we use reduced precision arithmetic or approximate carry sub representation to trade off accuracy for efficiency. Is that now we come on that. What are the general approaches to implementing approximate circuits? That there's so many approaches get possible. I already described several type of multiplication approaches and several types of adder approaches. That here I try to give you idea about the
थोड़ा थोड़ा ले लो किसी का पानी
general
मिल
practices
जाएगा।
that
हाँ थोड़ा जब पानी टेक्सचर हो
out
जाएगा
of them one
गलेगा
approach
नहीं
to
तब जलेगा।
implementing
साग
approximate
बना
circuit
देना
for
था। बड़ा हो
feed
जाएगा।
forward neural network is to
हाँ
use
बनाया होगा। कुछ
low
नहीं करना
precision
काट देना है
arithmetic
और डाल देना
instead
कढ़ाई
of
में।
using a standard
हमको बनाने को नहीं
32-bit or
आता।
64-bit
अबे
floating
कुछ
point
नहीं
arithmetic.
करना है खाली
Lower
सब कुछ
precision
चलाना है
arithmetic
बस।
such as 8-bit or even 4-bit
इसमें
arithmetic
पानी
can be used.
छोड़ना
That
है।
it reduces the number of operations required to perform the computation, which can lead to significant speed up in the computational time for the neural network. Another approach is used to approximate multiplication and addition operation, which can be faster and less complex than exact operations. For example, a multiplication operation can be approximated using a bit shift operation, which is much faster than a full multiplication operation. Similarly, an addition operation can be approximate using a rounding operation, which can be faster or less complex than exact addition operations. That another techniques for implementing approximate circuit for feed forward neural network, including pruning the network to remove unnecessary connections or node, and using quantization to reduce the number of unique values used in network weight and activation stack. Approximate circuits can lead to significant speed up in the computational times of neural network. They also come with a trade-off in accuracy. The use of approximate operation can introduce error in the computation, which can result in reduced accuracy compared to using exact operation. The use of approximate circuit must be carefully balanced with accuracy requirement for neural network for a given application. That's all from my side. That I try to cover in a fast pace. That now floor is open for questions. Answer that. If you have,
If anyone have any question, you can message that on group. Actually, sir, I have stopped the host control. I'll receive the question and then I'll share you just in
uh,
1 minute.
okay, sorry, I did not aware that. I think that it's open for everyone. That okay,
Actually, it was open for everyone in the starting, but later on I did it.
okay. Actually, I did not identify that. I reserve roughly 15 to 20 minutes for question sessions. That because mostly people have, especially in Atal FTP type of things, that people has loaded a lot of questions. That
Yes, sir. Yes, sir. But the presentation was very good, actually. So I think most of the things will be clear to them. Let
yeah,
me
i
see.
try to i try to cover in a brief way the entire approximate computing stat and how it contributed in many areas. Especially I focus on neural network, that which is one of the hot area, that especially in VLSI design, that till now like people are thinking that especially we talk about that AI, that AI is dedicated to computer side people's that. But big problem is that nowadays those are big companies that they are facing that they have lot of data and they needed some specific dedicated computing systems that. And
Okay.
nowadays
Yes, sir.
dedicated computing demands are more that, and it gets
Sir,
possible through the VLSI side only, that because no one software work efficiently without the exact hardware supports that. So there is a lot of role nowadays. VLSI people has a lot of role and responsibilities to computer science domain also. That
sir, one question is that the integration of image processing with VLSI design,
yeah,
does it work well like the software, like the MATLAB simulation tool, MATLAB? in which they are working. And I think their question was that faculty members were working in image processing on the software MATLAB or Python using that image processing toolbox. But
ये
how
मान लो
we
बेंच से
integrate that
बच्चा
image
पे खत्म
processing
बोलो
and machine learning tool in VLSI? I think that was the question.
Yeah, it's really nice question that actually there are two things get possible. One thing is that if we talk about that basically testing prospect, that we develop
मतलब ये
something
हमारे
that
पास
and we
बैलेंस में
want
तो
to
ले लिया
actually test the accuracy and all those things, and probability of
मेरे को पैसे बोलिए
prediction
तो मैं
probability,
अपना
those
पैसे
things.
वहाँ से ला
Then there
लेंगे
is a role of machine
ले
learning.
लिए पैसा ले
But
लिया
suppose till now what you implement that via Python or MATLAB tools or anything, that end of the day they are simulator based work. That till now if we did not dedicated hardware for that, it did not get feasible in a real world. I give you one example that um, I am the member of ISA community. That ISA is the premier VLSI promotion company, that and it's in that umbrella near about 250 plus 300 near about VLSI companies. That so in summer, that when temperature touch up to 52 and 54 in few places in India, that then there is a big debate get started inside that group, because all are VLSI companies honors that. Luckily, only few 20-30 teachers like we people are in that group. Rest all are company owners. That most of company owners, which has company net worth is 100 crore to 10,000 crores. That so they start debating that if such way temperature get increases in India, what are the test failure rate of our chips? That because chips are those are domestic chips, that mostly they develop in temperature range to 5 degree to 60 degree or 65 degree.
ऑरेंज ले क्या और आपने
So
ऑरेंज ले
only VLSI is only
मुझे
approach
ऑरेंज ले
that via that you can do that. If you start want that first stage is that for implementation purpose you use the FPGA boards, and then you need to jump on ASIC designs. That nowadays great thing is that Synopsys and Cadence type of premier tools
Black
and
man.
chip fabrication
Who
facilities are freely available through the C2S. That
तो वो पेरमा पानी लिए तो ये
so
लगा ले लिया
now our things are very easy, and it's a great environment right now in India for research regarding such type.
और जल्दी खत्म हो जाए
वो नहीं मिलता
Any
Okay.
other question, Dr.
Uh,
Abhishek?
ये साला
Sir, one more question.
Yeah.
Someone asking that using the ML algorithms and image processing, ML algorithms will ML algorithm may slow down the FPGA processing because it
निकला था लिखा
requires
हो ना
lots
तो
of
जो आपको ले
calculation
लिया
like
होगा
CNN or any other model. So image processing will increase the complexity and will reduce the processing time. So how
What
can we deal
area
with
he is
this?
talking that it's called neural network accelerators. Nowadays, till now there is a not dedicated hardware for neural network for that level of complex things. But it's a hot topic of research. That and those are Indian researchers, that many IT professors are continuously working in neural accelerators domain. That I am also working in that. So it's a just a start area in last 2-3 years, and hopefully next 2 or 3 years that dedicated VLSI chips get available for such type of processing and computing.
मारू अभी साला 3-4 का नहीं
FPGA is not suitable for such type of work.
दूगो
I see. Okay. I hope that will be clear to that person
दिनों बैठ के
also, and all of us as
आएगा
well.
भाषण दे रही है
So,
Any other question?
I think most of the people. I'll share your email ID and I'll receive the question, sir, for the later purpose, and I'll share it with you on your email ID
Okay,
so
okay,
that they
that's
can
great.
be get clearance over there.
Okay, okay.
सूतने पे तू
Okay.
Okay, thank you
Sir,
very
could
much,
you please
everyone.
कार्ड दइयो
ये सब thank you, and I
चलो बनाते हैं
sincerely thankful to Dr. Durgesh Nandan sir for
नहीं
receiving our
भूख लगा
request to
कस
be
के
part of this
बिना
FPP,
भूख लागला तो खाओ
and thank you so
बनाओ
much for this
चलो
good
चलो
session, sir. That will be really helpful for all of
इतना तो
us
बेंच पूरा हम ही खा
for
लिया
the teaching purpose and also especially for the
खा
research
लिया
purpose actually. So I am thankful to Dr. Durgesh
अरे
Nandan
बोल
sir. Thank you,
हाँ
sir.
Thank you, everyone. Thank you, Dr.
ठीक
Sip.
है बनाए क्या
Can I leave now?
शुरू तो
Sure. Thank you, sir.
Okay, once again, thank you, everyone.
Thank you, sir.
So I'm thankful to everyone
एनवी कौन सी में
for attending.
सागो का
मैं 4 बात कर
ठीक हो खा दिया थोड़ा थोड़ा मैं रह दिया एक मुट्ठी छोड़ दिया
कायला पूरा खा दूंगा भूख लगा लो